Now we've talked about cis-trans isomerization, but what happens when you have something that does have more than two of the same groups on a double bond? How do we assign that type of alkene? So again, when you have something that has groups that are the same on one side, even if this group and this group are different, we at least have one side with groups that are the same. So this would be a cis, for example. This double bond here, again, we have hydrogens on opposite carbons that are the same. And so we can name this as trans, because even though this group and this group are different, we have these hydrogens across carbons that are the same. So again, that completes our rule for cis-trans. But what if you have something like this? Here's a double bond. Okay, when we look at its groups, this one has a CH3 and a CH3 across from each other. So it's okay, it can be named as trans. But this double bond here does not have any groups that are the same within a carbon or across carbons. We have all four different groups. Same with this double bond and also with this double bond. All four different groups on the carbon. Cis and trans fails in this type of situation. So where alkenes that are geometric isomers, meaning they have the same molecular formula, but they cannot interconvert through rotation, and they have four different groups attached to the double bond. We can't use cis and trans here, and instead we use a nomenclature that is called E and Z. To assign an E or a Z configuration, you first have to prioritize the groups attached to each carbon. And this is relative to one another. So first, you want to find the higher priority group on each carbon. Again, you're going to think about it on each carbon, assign the higher priority group. If the higher priority groups are cis, meaning that they're on the same side, it gets the Z. If the higher priority groups are trans or on the opposite sides, it gets the E name. So generally, Z is going to resemble cis and E is going to resemble trans. Let's look at a breakdown for these assignments. Again, generally, you have a double bond, has four different groups on it. You want to split this double bond down the middle and think about each of the halves first. So we're looking at this in halves. Then you want to rank the two atoms directly attached to these individual carbons based on their atomic number. Ranking in this system is just like we did ranking for chirality. The bigger the atomic number, the higher the priority. So here we, for example, have a bromine and a fluorine. So bromine gets higher priority and fluorine gets lower priority. Now, let's look at the other side. We have a chlorine and a methyl. In this case, chlorine is a higher atomic number than the carbon, so it will get higher priority. Now you just want to look at the numbers you've assigned on each side. Here, we have 1 and 1 priority together and 2 and 2 priority together. So this gets the Z configuration, which is the same as cis. And to remember the cis and the Z is that we sometimes say Z same side. So Z is when they're on the same side. And E is when they are on opposite sides. So in this example here, where we have fluorine, which is 2, and bromine, which is 1 on this side. And when we assign this side, chlorine gets 1 and methyl gets 2. And thus our 1s are on opposite sides, and same with the 2s, so this gets E. What happens when you have to break a tie? Again, this is going to be the same rules that we looked at for chirality. So for example, in this molecule here, if I look at this side first, we're going to assign the bromine as 1 because when we compare the other substituent, it will be a carbon, which is lower in atomic number than bromine, and so these are numbered 1 and 2. But what if we look on the other side? The first thing that is attached to each side of these double bonds are carbons, and so they have identical atomic weights. So what you want to do is then, just like in our chirality, go one by one and look at what those carbons are attached to. So this carbon on the top is attached directly to 2 hydrogens and another carbon. That's carbon, hydrogen, hydrogen. This carbon here is again directly attached to 2 hydrogens and a carbon. So yet again, these are the same. So we'll move one more space over and see if we find any differences in priority there. When we move one more over, we're looking now at this carbon and this carbon. This one at the top is attached to an oxygen and a hydrogen and a hydrogen. Remember, this is what it's directly attached to. And this one below is attached to a carbon, and a hydrogen. So when we look at these now, you can see that the top one will get priority because as we go one by one, the first point of difference, this has an oxygen, which is higher in atomic number. And remember, that's the main thing we're looking at, atomic number. Oxygen is atomic number, or is higher than carbon. So even though there are 2 carbons here, this group will get priority. So it will get the 1 and this will get the 2. So in this case, after we've assigned priorities to each side, you can see our 1s are together and our 2s are together. And so this is a Z, the same side. Okay, let's do some practice looking at drawing and naming, especially naming these compounds based on using the E and Z configuration and also our newly naming ene configuration we've talked about. In this question, we're asked to draw Z 2-bromo 3-methyl hex 2-ene. And again, I like to break these up into chunks and then fit them together when I draw. The first thing I'm going to look at is the main length of the compound. It's a hex, that's 6, ene, so it has a double bond. So first let's draw 1, 2, 3, 4, 5, 6. Where is our double bond? It's on position 2. 1, 2. Okay, we've done that so far. Now let's look at our substituents. We have a methyl group on position 3. And we have a bromo group on position 2. Now, I may have to redraw this to satisfy the correct E and Z configuration. That's okay. Let's think first how our double bond is set up and then decide how we can rearrange it if we need to rearrange it to make it the E or Z configuration. Currently, when I look at each carbon along the double bond in my drawn configuration, if I look here and want to assign priority, the bromine will get 1 and the methyl group will get 2. And when I assign priority on this side, my long chain will get 1 and my methyl group will get 2. Currently, the way that this is drawn, we have our 1s on the same side and the 2s on the same side, meaning that this is the Z configuration. Now, what if my name said E instead of Z? If it said E, I would have to redraw this so that my 1s and 2s were on opposite sides. And to do that, you generally just want to pick one of these groups and switch it with the other. So for example, I could just flip my methyl and my bromine around, and that would easily give me my correct positioning. So everything else the same. Now I'm going to draw my bromine here. Notice I did not move the placement of bonds, right? My double bond is still in the same place. My methyl is still in the same place. Everything is still connected in the same way. I just flipped one of the groups around. So this case, drawn in this way, would be our E configuration, because now if I assign my priorities, you would see that they are on opposite sides. Okay, let's try a naming problem. Here's naming. It contains a double bond. And because it contains a double bond, we have to think about our E and Z configuration as well. All right, so first let's find the longest chain that contains the double bond. If we look, it would be this chain right here, which is 7 long. So we know this is going to be a heptene. Now we want to number where the double bond is, and remember we want to give that the lowest number priority. And if I number starting from this side, this would be 1, 2, 3, 4, 5, 6, 7. So our double bond starts at position 3. So this would be hep 3-ene, hept 3-ene. Now let's add in any other groups that we have. You can see there's this methyl here and this methyl here. Remember, when we have 2 of a group, we're going to say dimethyl. And we want the numbers for that position. So this is 3, 5 dimethyl. That's how you would name the groups. And let's add the rest on, hept 3-ene. So here is the final name for this structure. Okay, let's try another one. Oh, sorry, I forgot to look at our E and Z configuration before moving on. E and Z configuration for this double bond, we're going to again split it in half and look at our groups on each side and assign them priority. Let me erase these numbers first. Okay, so here at this double bond, split it in half, look at this carbon first. We give priority to the longer group here. And on this side, remember that there is a hydrogen here. So as drawn, this would get priority here, and the hydrogen would get this. You can see our 1s and 2s are opposite of each other. And so as drawn, this would be an E, and this goes in parentheses, 3,5-dimethyl hept 3E. Okay, now we have the full name. Now let's try this particular double bond. Here we have a ring, and it is a 5-membered ring. And I want to remind you that when we have double bonds in rings that are smaller than size 7, they are always in the cis configuration. So here we don't really have to think too hard about how we would name this via cis or trans, because we know that for a small size ring, because of the strain, this is going to be a cis. The ring here is 5 long, so it is a cyclo. Remember to write cyclo because it's a ring. Pentene. Now, if we wanted to name this for its position along the ring as far as the double bond, we're going to number based on our substituents. Now, both sides of this double bond actually have a substituent on it. And so I am going to choose based on the higher priority substituent, which in this case would be bromine. And remember, this picking bromine over a methyl group has to do with those naming rules we talked about in our halides. So halides get priority in their number as opposed to any alkyl groups. But alcohols get highest priority even over double bonds if you had an alcohol. So here we'd start numbering at this position and go around. So we'd have a 1 bromo. We also have a 2 methyl, and we know that this is cis. Now, to write these in order, remember that we write the extra groups in alphabetical order. So this does happen to have the lowest number, but don't write them based on their number, write them based on alphabetical order. So this would be 1 bromo, 2 methyl, cyclopentene. And in front, we're going to write cis. Just as a reminder, anything that is distinguishing stereochemistry like cis, trans, E, Z, and we've talked about R and S, these always go in the very front of the name. in parentheses.